Ansys Mechanical APDL. Ada recorded tak? Saya nak tengok, check. Boleh record tak this presentation? Saya tak nampak pula boleh record. Okay, doesn't matter lah. Alright, so continue with the presentation of the Ansys. Okay. And the objective of this problem is to demonstrate the basic Ansys procedures for performing a simple Ansys. This problem is a simple two-dimensional static structure problem or simple bracket yang ada macam bulat, hujung dia semicircle dan ada 3 lubang dalam the bracket tu. Okay, it is still what you call that? Steel structure with modulus of elasticity of 200 gigapascal. Poisson ratio is 0.3 and density is 860 kilogram per meter cube. We're not going to use this what you call density here. Alright, so straight buat dia punya tutorial, Ansys tutorial. Okay, first of all, you have to rename the file, change your name. Let's say tutorial 1.0. Okay. And then change title. Plain bracket with 3 holes, katakan. And then select OK. Okay, for this one, a lot of function will be introduced, and please bear with me. And then kalau kalau you tak follow, and then you can always follow the YouTube channel yang orang lain buat lah. Okay, mesti ada punya, don't worry. Alright, now we want to have a preprocessor. Preference dulu lah. Okay, we are doing a structural problem. Alright. Okay, preprocessor, modeling, create areas, rectangle, and by 2 corners. Pop-up menu will appear. So what we do, we write 0. Okay, dalam Ansys ni dia tak pakai arrow atau tab. You have to use the mouse. 100 and 100. Okay. Okay. Now the new thing, we have a bracket Now we have a complete square diagram over here. So let me capture this first. All right. Square box like this, and then the next step we want to buat a circle at the end of this box ataupun square. Preprocessor, now we are doing a circle, okay, a solid circle, okay, and now we can write dia punya position of the x point is 100, and this is center of the circle, and the radius of the circle is also 50. Press OK. Okay, now we have a box and a circle. You nampak yang line kelabu dekat sini. This is a circle. We need to merge this circle. Alright. Now we can tengok dia punya difference by using numberings over here. Okay, in the plot controls, in the command line plot controls, bukan command line, this is menu, yeah. Numbering. Okay, when we select numbering, kita akan we are giving pilihan over here sama ada kita nak numbers and color, okay, ataupun no numbers and no color. So line we just bagi ada line numbers, area numbers, volume numbers tak perlu. Not numbers kita boleh buat tapi akan jadi banyak serabut based on kita punya element structure. So dalam elements ni we can use element numbers. Okay. Element numbers. Bila ada element numbers ni dia akan bagi color sekali. Okay. Now we have two different apa components, yeah, a square component and a circle component. So we want to merge these two, jadikan dia one, okay, by using preprocessor. Now we want to operate. Operate, we use boolean, and we have to add areas. Okay, pick one area and another area. For this one doesn't matter which area we pick first because dia akan add saja. Okay, now we have a single structure saja which is labeled by A3. A3 is area 3. L kat sini is line, A is the area. Alright. Now we want to have what you call that? Want to have a bigger circle over here. Okay. Want to have a bigger circle over here and want to subtract it so that we can have a bigger hole over here. Okay, how to do that? Modeling, create, circle, solid circle, and then this is where we want to put, okay, 100, and WPY is 50, and the radius now is 30, smaller radius, and then okay, now we have a smaller structure over here. Okay, and then we have to subtract this small circle to make a hole of this bracket. Okay, select operate. Okay, booleans, and we have to subtract areas. Okay, first we want to have a bigger thing over here. All right, be okay, and then a small holes here, click OK, and now we have a hole inside here. All right, and now we have to have a fillet at this corner and this corner. How is that? Okay, we to create fillet, it will be no plot lines, preprocessor, modeling, create lines, and then line fillet. Lines. Okay, place down line fillet. Okay, first we pick over here and this one, and then press OK. Okay, how many radius that you want? Fillet radius. All right. And then according to tutorial, we pick 20 as a radius, and this box leave it blank, and then press OK. Now we have a new fillet line. Okay, we create another fillet over here. Press OK, and then check numbers here, and then press OK. Now we have line 8 and line 3, a new fillet line. Now we have to take out this corner here. We don't want. Okay, how to do that? Okay, we have to create area low before we can okay, in the boolean operate, boolean we have to subtract areas. Okay, we want to have the main thing is this one. Okay, and then the thing that we don't want is unpick. We don't want here. If we not sure, we cancel first and then save our DB first. Okay. Oh, we have to create the area first. Okay. Area, because we are this one is not defined as area yet. Main menu, preprocessor, modeling, create areas. Okay. Create areas. areas, mana create areas, by lines, mana by lines, arbitrary, arbitrary by lines. Okay, so we pick, press OK, and then repeat the process. 1, 2, 3. Press OK. Okay, now we have a area that we can subtract later on. Operate, Boolean, subtract, areas. Okay, the bigger area. Select OK. And smaller area. Press OK. Okay, now we have a bracket like this. Okay. So we can have a new holes. We have to create two holes, one over here and one over here. Okay, how to do that? Okay, modeling, create circle area, create area, circle, mana circle? Circle, solid circle. Okay, and according to tutorial, WPX number 1 is 20, 20, and radius is 10. All right, and then create another solid circle, which is 20, 80, and 10. Okay, now we have two circles. Okay, we have to operate, subtract areas, the main area, select OK, and then the smaller circle that we don't want. All right, tekan OK. All right, now we have a bracket with 3 holes. Okay, let me capture this thing and share. Okay, yang you akan nampak the timestamp ni ya, tarikh, today tarikh, and then this is the time that I completed, that I begin this tutorial. Ya boleh nampak, so tak boleh tipu lah unless kalau you pakai software untuk bikin this one lah, so akan nampak lah. And then what is the next step? We want to okay, save DB first. Want to assign element type, real constant, and material properties. Okay. Element type, preprocessor and element type. Add, delete, non-defined. You have to add. Okay. Still solid. Solid. Okay. Quad 8 node. 4 node. Masih lagi 4 node. And then okay. And then option. Okay. Plane stress, width, thickness. Okay. All right. And then after that, we have to define the real constant. Okay. We have to define the real constant. add, delete, none defined. We have to add. Okay, this plane 182. Ada thickness dia berapa? 20 mm. Okay. Close. And then material properties. The material properties. Material models. Structural. Linear. Elastic. Isotropic. Okay, for this one, 200,000. 0.3. Okay, cross. Okay, dalam tutorial ni, dia import library, dia apa? Material library. Kita tengok apa yang ada. If we have material library path. Okay, we don't have, we tak install. Okay, and then we just try to import library. Okay, SI units. We don't have file. And then cancel je lah. Alright. Now the meshing process. Let's close this thing. Okay, now the meshing process. We have to mesh. Kita dah buat geometry, kita dah assign material properties, real constant and element type. Now we want to have a meshing before we can go further. Okay, preprocessor meshing, bukan modeling ya, meshing. Okay, want to create how the size of the mesh is picking the size control. We can either pick a smart size or manual size, but I prefer to do the manual size first, and then areas, and then all areas, and then the element size that you want. What is the element size that you want? Okay, katakan 10. Okay, because this length is about 150. So kalau 10 biasanya kita akan ada around 10 atau 15 element along from the beginning here to the end. Kita akan ada 15 elemen. Saya ketikkan sikit lah bagi fine sikit. Alright. Elemen length 5. Okay. And then main menu, kita want to mesh areas, pre, we pick the bracket, and then we try to see. Okay, now this is how the mesh looks like. Okay, ada 3 triangle element, doesn't matter lah. Okay, this dia hanya bagi tahu bahawa ada triangle element dan dia akan ada stiff bending. Okay, yang colorful ni, this is because what you do the in the plot control this one numbering. Okay, dalam elemen numbers ni. Kalau you undo the element numbers, okay, and then no, let's say kalau you pick no numbers, akan blank lah, tak colorful lah. Yeah, tengok, it's not colorful anymore. Okay, so the matter we can proceed now. So let me capture this gambar the process to show you the steps. Okay, now we can go into analyze the thing. Saya rasa dah almost siap. Okay, we save DB and then file save as .namedb. We save our work. Okay, now we dah finish first process in the pre-process phase. Now we are going to the solution phase. Okay, the analysis type we have a new analysis, which is a static analysis. Press OK, and then we can define loads. All right. For loads, for this is the boundary condition. Want to have, okay, these holes we are welding to the let's say whatever vertical surface lah, and we are hanging something on this part. These two holes we weld the holes into the vertical surface. Apply. Okay. Structural displacement on lines. Okay, we pick the circle line. Ada 4 lines and this another 4. And press OK. Okay, and all do F. All do F 0, meaning that these holes are fixed to the wall. They're not moving. See? All the symbols now meaning that they are fixed. All right. And now we have a load application. We want to apply the load. Okay. Apply structural force moment on key points. Okay. Kita ambil at the bottom part of this bigger circle. Press OK. Okay. The direction is Fy. And it is a constant value. And since it's downward, we pick minus 1000. Okay. Okay, now you see dia punya load is vertical and at this point. Let me capture this section. Alright. Bila dah habis, Now into the solution. We can solve this problem. Are you ready to solve? Bismillahirrahmanirrahim. We can solve the current as. Okay, Bismillah. Okay, solution is done with no hiccup or no problem at all. Okay, close and cross the thing. Okay, post processing. Now we are done with the what call that? Second phase, which is solution. Now we are going into the third phase, which is post processing. Okay, so you have to read result first. First set. Okay, after you read result, okay lah. Okay, and then you can plot results. Deform shape, deform and undeform. Okay, now you see, yeah. Yeah, undeformed is the black and the blue is a deformed model. So you can use dalam your final project kalau for those of you who taking the final project in terms of structure, you can apply this Ansys. All right. So and then we see the actually we can animate this one, but I don't remember yet the instruction. Deform shape we can animate, we can tengok dia punya animation. Okay, how it does the deform and undeform. Okay, now we see the contour plot. Okay, the contour plot. We see the nodal solution. Contour plot, nodal solution. Nodal solution. And then we are taking the stress. And then kita tengok von Mises stress. But student suka sangat tengok von Mises stress, jadi kita pun tengok the von Mises stress. How it looks like. Yeah, just like this. Yeah. The blue part is the low stress and the red part is the high stress. You can see dia punya stress di sini kat sini. Okay. So let me capture this photo for you to refer. Sepatutnya lebih kurang macam ni lah, nampak lebih kurang macam ni ya. Alright, and then modify this is the thing that we should see. Okay, saya tengok dia punya we call that the line element, nodal element solution, the apa displacement result element solution ni. Element solution strain the okay, not this one. Still under nodal solution, that's silap saja. Okay. The F solution. Okay. The F solution lah. Okay. And tengok dia punya displacement in terms of Y. Okay, this is the displacement contour plot. Displacement, the x component of the displacement. Okay, this one is the x component of displacement, and this is the sum of the displacement. Okay, this is the sum of displacement. Actually, this one is bau contour plot. You can kalau you nak tengok the detail plot, you can I think dalam list result, bukan tin film, list result. Element table turn nodal loads. Detail summary bukan. Iteration summary percentage error source deleting. I think it's a nodal solution lah. Nodal solution, DOF solution, DOF solution. Displacement in X component, in Y component, you boleh tengok. Yep. In Y component, you can tengok, you boleh tengok dalam kat sini. Provided you know where is the nodes lah. Okay. And cara nak tahu nodes kat mana, you can always play with the plot controls, numbering, and number of nodes. Apply. Ataupun okay. Okay, the number of nodes here nampak 1, 3 is the apa yang rendah sekali. Okay, and then you can refer back to this table. Okay, you can tahu dia punya displacement in Y direction kat mana. So I guess this is dia punya cara-cara nak cari apa displacement dengan nodes. That's how you identify the nodes and the displacement. Okay. Save DB. Save. All right. I guess that's all for today. And I hope that you have learned something how to play around with the basic introduction of Ansys. This is the most, the simplest way of playing around with Ansys. Ada lagi banyak lagi complex structure. You can use Ansys workbench kalau you ada complex structure. Okay, dekat sini ya, Ansys workbench. Ansys ABL kalau you ada structure yang simple like this lah. Okay, kalau ada more complex structure, you have to use the Ansys workbench where you can buat dia punya the CAD model dalam Katia and then import into Ansys dan buat analysis. Okay, with that, any question?